Okay, today we start the weekly test paper 3. Right, test paper 3. Right. The first question given, a not equal to 0, the roots of the equation ax squared plus bx plus c equals 0 are alpha and beta. Prove that alpha plus beta minus b over a and alpha beta c over a. Right. So now here we suppose to take like this. We are given the roots of this equation ax squared plus bx plus c, ax squared plus bx plus c equals 0. This has the roots alpha and beta. Okay, right. Now I am going to write the quadratic equation with the root alpha and beta. Right. The equation with the roots alpha and beta is, when we are given the roots, the way of writing the quadratic equation. How to write that, people? Yeah, x squared minus sum of the roots times x plus product of the roots is equal to 0. Right? Okay. So this equation will take as number 1, this equation number 2. Right. So then equation number 1 is having the roots alpha beta. Equation number 2 also has roots alpha beta. Then for the equations 1 and 2, the same roots available. When two quadratic equations have the same roots, between that two quadratic equations, there's a particular property. What is the property? The coefficients of x squared coefficient, the ratio, if you can take the ratio of the x squared coefficients equal to ratio of the x coefficients equal to ratio of the constants. So that is the property when two quadratic equations have what the same roots. Okay. Then since 1 and 2 have the same roots, we may write, yes, what? Here, this coefficient is 1 divided by ax squared coefficient is a. X coefficient here minus alpha plus beta, here it's b. Right? Here alpha beta, it is c. Okay. Now we can take these two together. We can take one result. 1 upon a is equal to minus alpha plus beta upon b. Bring this here, multiply both sides by minus sign, write alpha plus beta. Alpha plus beta is minus b over a. And secondly, equate these two, what? This and this. 1 over a is equal to alpha beta upon c. All right, use this way. Alpha beta is equal to c upon a. Right. So this is how we take the first answers. Right. Okay, next one. Next part asking this way. If alpha over beta equals lambda over mu, then show that this answer. Right. Now we have the results. These. First one, we just now proved this alpha plus beta minus b upon a, number 1, alpha beta c upon a, number 2, no? Right. 1 dash and 2 dash will take, because 1 and 2 we have used, no? Right. Now, also given this, also alpha upon beta is equal to lambda upon mu. This is given. Right. By this, we can subject alpha, use the cross multiplication to this in lambda upon mu beta. Okay. Then, by 1 dash we can write here, substitute for this alpha here. Alpha is this lambda upon mu beta plus beta minus b upon a. Take this beta out and take mu as the common denominator. Here we get lambda plus mu is minus b upon a. Okay. Now, by this we'll subject beta. Bring this mu here, lambda plus mu here, minus b mu divided by lambda plus mu times a, right? Okay. Now what we next do is this beta, right? And here 2 dash for alpha, we substitute this, beta, we substitute this. Then we get the next answer, right? Now by 2 dash, what can we say? Alpha beta is c upon a, no? Right. What is alpha? Lambda over mu. Lambda over mu. Beta, and another beta is there, c upon a. Then we can write, what is the answer asking? Yes, lambda mu b squared, no? Right. So then I can write here lambda over mu beta squared is equal to c upon a, right? Lambda upon mu beta squared. I'll square this. It is b squared mu squared divided by lambda plus mu perfect squared and a squared is equal to c upon a. This way, right? Now 1 mu you can cancel out with this. 1 a you can cancel out with this. Then the answer lambda mu b squared here, lambda mu here we have lambda mu b squared is equal to AC into lambda plus mu squared, lambda plus mu perfect squared into AC. This way we take that answer. Okay. Next one. Next one says something something like this. If the equation ax squared plus bx plus c equals 0 has equal roots, ask you to show b squared equals 4ac. Right. Then we can start that like this. If the equation ax squared plus bx plus c is equal to 0 has equal roots, then we can say what? Alpha equals beta. So dividing both sides by beta, we get alpha by beta is equal to 1. But people, we are given this alpha over beta is equal to lambda upon mu. Then I can write here alpha over beta is equal to lambda upon mu is equal to 1. This gives us lambda equals mu. That means when the two roots alpha beta are same, that means only one root, no? Coincident roots, no? Lambda equals mu. Now what we do is, here the result we proved lambda mu into this, no? here we put lambda mu equal. Now, by that answer, lambda mu b squared is equal to lambda plus mu perfect squared AC. I can put lambda equals mu, lambda and mu here. For this mu, put lambda, then lambda squared we get b squared. Here for the mu, put lambda, lambda plus lambda perfect squared AC, right? Lambda squared b squared. Here lambda, lambda 2 lambda perfect squared AC. Lambda squared b squared. Here 4 lambda squared AC. These two you can cancel down. B squared equals 4AC. This way we get that answer too. Right. Next one asking. Also, if the ratio of the roots of the equations ax squared plus bx plus c equals 0 and px squared plus qx plus r equals 0 are equal, show that pr b squared equals ac q squared. Okay. Now, I'm going to think it like this. Now, we are given ax squared plus bx plus c equals 0, no? Right. Here, its roots, I'm going to assume as alpha beta, that is given, no? Right. Anyway, alpha beta, right. I'm going to take alpha over beta, the ratio of the roots. No? I'm going to take as lambda upon mu. Okay? And now the second equation, px squared plus qx plus r equals 0. I'm going to assume the roots of this as gamma delta. Then gamma over delta, right? Okay? Gamma over delta. Here we have alpha over beta. That means ratio of the two roots of this equation. No? Here this equation has the two roots gamma delta. Gamma over delta, ratio of the two roots of this equation. We are given in the question this ratio and this ratio equal. If this ratio I have assumed as lambda upon mu, since these two are equal, this also I can assume as lambda upon mu. Right. Okay. Now, earlier we proved for this equation this type of result. Okay, that we proved, no? Now, the same result is still valid for this equation. Then I am going to write that lambda mu b squared equals lambda plus mu, right, squared AC. I take this as, right, result simple A. Okay. Now people, a similar result we can write for this in the same way. Only thing is people, this b is the x coefficient, no? For the place of b, we have to put q. Lambda mu same. AC, x squared coefficient is a, constant is c. Here it is p and r. Then same result we can write by the first proof for the second equation this. Right? Similarly, we can write, what can we write here? Lambda mu, b means the x coefficient squared, no? Right? So here it is q. Q squared is equal to lambda plus mu perfect squared. AC means this product, no? B R. All right, this is B. Right. Now, divide A by B, then we get the next answer, right? When you divide A by B, right? A by b, we divide a by b, then lambda mu b squared divided by lambda mu q squared is equal to lambda plus mu perfect squared AC lambda plus mu perfect squared PR. Here you can cancel down this 2, this 2, use the cross multiplication, b squared PR, q squared is, this is how we take that answer. Right, right, question number, next, question number 2. Right, question number 2. Number 2 says, sketch the graph of the function y equals x into x minus 2, right? Okay, y equals x into x minus 2. First we'll write roots, right? To find the roots, y we have to equate 0, x times x minus 2 is equal to 0, then here we get x0, x minus 2 0, the two roots are 2 and 0. Okay, the two roots are 2 and 0, right? And also this is the graph, right? Because x squared coefficient is positive, therefore the graph is minimum. Then we can sketch the graph. Right, this graph has the x at vertex, right? X coordinate of the vertex, we can take, add in the roots and dividing by 2. It is nothing but 1. Y at vertex, we can obtain y coordinate at the vertex. We can obtain here x coordinate at the vertex is 1. Put that here. 1 minus 2 minus 1 into plus 1 is minus 1. Right. Then vertex is 1 minus 1. Then we can sketch the graph. This way we can sketch the graph. The vertex is 1 minus 1, this here, right? Here 1, here minus 1, vertex here. Right. Then the graph passes through this point, and the other coordinates, root is 2, no, here. 2. And the graph is this, no? This here, right? Y-axis and this is x-axis. This is 1 point, 1 minus 1 point. Okay. Now, on the same diagram, sketch the graph of the functions y equals x squared minus 2x and y equals 2x minus 1. Y equals x squared minus 2x modulus graph, next one asking, right? Y equals x squared minus 2x modulus graph, right? Here we can write this. Also take this x out, we can write it as this, no? Then the y equals modulus x squared minus 2x graph mean modulus of this graph. Okay? Modulus graph of this. Asking to draw. So then modulus graph mean, you know, the modulus graph can be drawn. We have to take the mirror image of this part. Right? This part, we take the mirror image through x-axis, leaving the other parts without changing. No? So then this 1 minus 1 goes to 1 plus 1 like this. Right? Here plus 1. Then the mirror image going to be like this. Right. Then other two branches being the same. So therefore I draw like this. The same black one I am drawing, but to get a clear idea, I draw that, keeping this black curve also at the side like this. This blue one is therefore the modulus graph. This point is 1, 1. Correct, no? Now next one, asking to draw on the same diagram the graph of y equals mod 2x minus 1. Mod 2x minus 1. No? Mod 2x minus 1. Right. We'll define the mod 2x minus 1. Y equals mod 2x minus 1. Right. Then we'll first define the modulus of 2x minus 1. Then this modulus value changes at x equals half. Here half 2x minus 1 modulus. On the right of half, the same 2x minus 1, we know that. On the left of half, 2x minus modulus will be equal to minus of this, multiply this by minus sign. Minus 2x plus 1. Okay. Then this graph we can draw. First one I am going to take when x greater than or equal to half. On the right of this. Modulus of 2x minus 1 takes this, then this place will be 2x minus 1. This is the graph we must draw on the right of half. On the left of half, what is the graph for this we must draw? Y equals, right, so 2x minus 1 modulus on the left of half takes this, no? Y minus 2x plus 1. Okay. So you know when we draw a straight line, we need 2 points, but definitely we know this half we have to put here, right, to find 1 point. Then when x equals half, put here half, we get 2 and 2 we can cancel down, 1 minus 1 is 0, half 0, right? Half 0 means people here, right, this is the point half, right? And another point we need to draw that, it is minus 1, the intercept, 0 minus 1. The intercept of this is what? Minus 1, no? Then the line cuts the y-axis at 0 minus 1. It is this point, no? Right. So then this point and this point we have to join. By joining that, right, we have to produce that line. Actually, to draw the complete line given by this, y equals 2x minus 1, by joining these 2 points to both directions we have to produce. But this graph we need only the range x greater than half. On the right of half only we need. So therefore, we join these 2 points like this, right? And then that we produce on the right of half like this. This way we produce it. This way we produce it. We produce it this way, right? You can see this point is 1, 1. This point is 1, 1. This line is passing through this point 1, 1. How do you verify that? When you put x equals 1 here, put x equals 1. 2 into 1 is 2, 2 minus 1 is 1. That means y also 1. It says this line passing through the point 1, 1. Therefore, definitely in your diagram that property should be available. Right? Okay. This way it is passing now. No? Right. So then other side, this one, there are also people we put x equals half here. When you put x equals half, y 0, right? Half y 0, right? Now, sometimes this is, of course, we take on the interval x less than half, no? Right? Then somebody might say, since x less than half, you can't put half here. That's true. But really remember, this is what I'm going to do. Without considering this way a range, I supposed to draw the whole line. Whole line. Okay? I am not going to consider the range of x less than half. I need to draw this whole line. Then we can put x half. Here, I put that half, minus 1 plus 1, y 0. Okay? Another x coordinate I can put x 0. That means the intercept. Here the intercept is 1. Then another point on this line, 0, 1. Then I told you that I need to draw the whole line. No? Then when we draw the whole line, that line passing through this point and this point. Okay? Then if I need to draw the whole line, I must join these 2 points, and to this end we have to produce, and to this end we have to produce. That's the whole line. But now I consider I need of that line only the part on the left of half. Therefore, I make sure to join these 2 points like this, right, and produce to this end only. Produce to this end only, right. Right. So then we have the complete graph, right. So then here this graph cuts this graph here, and the blue one also cut it like that. This right. Okay. Now all the diagrams we drew clearly, right. Now asking something like this. Yes, I will take this point as C, this point as D, this point as A, this point as B. Now I am going to find these points C, D, and B x values, right? Okay, point C you can find like this. Yeah, point C is right. Let's see how to find point C. Point C is the intersection of this black one and this black one, blue one. Actually, black one, they have the same equation, right? This straight line black one, right, has the equation this. Then we have to solve that too, no? How to solve? Solving. So I am writing point C. Point C. Now I am going to find first. Solving what? Y equals this curve given by this, no? Right. X squared minus 2x. And y, this black line is this, no? Minus 2x plus 1. Minus 2x plus 1. Now solve means equate y. X squared minus 2x is equal to minus 2x plus 1. This 2 you can cancel down. X squared plus 1. Then x is plus 2 minus 1, right? So this x coordinate of the point C cannot be plus 1 because it is on the left of y-axis, no? So therefore it is a negative 1. Out of these two, we have to take the minus sign. Therefore, xc is minus 1. Right. This is how we take x coordinate of C. Right. Next one, we need this point D. Right. You know, this blue equation, it is a mirror image of this black one, no? When you take the mirror image, mean the right hand side of this equation should be multiplied by minus sign. Then only we get the equation of this blue one. So the black one has the equation this, no? Once it multiplied by minus sign, only we get the blue one. Then to find the point D, we have to solve this line. Y equals, this equation is minus 2x plus 1, no? Minus 2x plus 1 and what? Y equals, here the blue one. Blue one has the equation minus x times x minus 2. Right. Then, when you solve this, we get this way. Equate minus 2x plus 1 is equal to this minus x times x minus 2. Right. Here, remove the bracket, minus x squared, take to this left hand side plus x squared. Here plus 2x and take that left hand side minus 2x with this minus 2x minus 4x and plus 1 equals 0. We'll write here the solution for x by using the quadratic formula, right? X equals minus b 4 minus b plus or minus square root b squared minus 4ac, here 4 divided by 2a. Okay. Then I can take here 6 minus 4, 12. 12 means 4 root 3. Square root of 4 is 2. 2 root 3 by 2. Dividing by 2, we get 2 plus 4 minus root 3. Okay. Then the x coordinate of this D should definitely less than this 2, no? Because that's well obvious, the point D lies on the left of 2. Here, therefore, we have to select the minus sign, xd. 2 minus root 3. Okay. And the one more, that is that point B. Right? Point B. Okay, then xd, 2 minus root 3. Next one, point B. Point B. Point B is the intersection of this line. It is 2x plus 1. And the blue or the black both have the same equation, x squared minus 2x. Right. We can solve it. Solving y 2x plus 1, 2x minus 1, no? 2x minus 1. And y equals x squared minus 2x. X squared minus 2x, we had solved with 2x minus 1. Right. Here, x squared minus 2x, equate this and this. 2x minus 1, x squared minus 4x plus 1 equals 0. Right. Then you can see here the same equation only we get here. X squared minus 4x plus 1 equals 0. Okay. Then if this has two roots like this, 2 plus root 3 value should be for the exponent of b. Therefore, this answers we know. It is 2 plus or minus root 3, we found no. Therefore, xb should be 2 plus root 3. Right. Now, what is asking? Next one asking, this in mod x squared minus 2x is then no equal to mod 2x minus 1. Okay. It means the blue graph, the blue graph should be less than or equal to the black V-shaped graph. That means the black V-shaped graph should be above the blue one. You can see the black V-shaped graph is this, no? That is above the blue one between minus 1. Here my exponent is minus 1, no? And here we found the exponent of d, 2 minus root 3. So therefore, one interval, the black graph is above the blue one is from minus 1 up to this. And the same thing becomes true between A and B. 1 and is, B is that answer, right? So therefore, occurs, this one occurs in what? X greater than or equal to minus 1 on the right of minus 1 and left of exponent of d. Exponent of d 2 minus root 3 is here. Here we put equal sign because he is asking they are equal also. In this interval, and another interval is there, right? And another interval, what is that? Here, exponent of b. Exponent of b we know, 2 plus root 3 no. And then on the right of 1 and left of 2 plus root 3. X left of 2 plus root 3n and greater than or equal to 1. In these two intervals, this and this both intervals, that inequality becomes true. Correct? No? 2 plus root 3 left and on the right of 1. Correct? This and correct. Okay, no? Right. Okay, the next part, number 3. Okay, number 3. Find the general solution of the equation tan 3 theta equals 1. Tan 3 theta equals 1. General solution is asking. Number 3. Tan 3 theta equals 1. Tan 3 theta, I can write this right hand side 1 as pi by 4, tan pi by 4. Then, right, we can write the general solution here. 3 theta is equal to n pi plus pi by 4 divided by 3 n pi by 3 plus pi by 12. N is an integer. Right. Now, next one we can write, asking to write the general solutions. Write down the formula for tan 3 theta. Tan 3 theta formula. Tan 3 theta formula, you know, 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Right? Tan 3 theta formula. Tan 3 theta formula is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Now asking what? Hence show that the equation tan 3 theta equals 1 can be written as this way. Now tan 3 theta equals 1. Okay. Right. This one. For tan 3 theta, we substitute this. We are here. Right. Right. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta should be equal to 1. Use cross multiplication. 3 tan theta minus tan cube theta equals 1 minus 3 tan square theta. Okay. Now we will multiply this by minus sign, and meantime all the terms we take to left hand side. Then here we get tan cube theta plus 3 tan square theta minus 3 tan theta plus 1 equals 0. Okay. Right. Yes, here we have a mistake. No, when we take this to this side, plus 3 tan square theta, but we multiply by minus sign. No, minus. Right. And okay, this way we get tan cube theta minus 3 tan square theta minus 3 tan theta plus 1 equals 0. Right. Now next one asking this way, where x equals tan theta. Right. Now we put for tan theta x. Then I can write this equation x cube minus 3x squared minus 3x plus 1 equals 0. Right. This way we get. Right. There, this x is what? Tan theta. X is tan theta. Right. Now what is asking next? Right. Okay. Now here this two equations you have to very carefully understand. Here tan 3 theta equals 1. I solved for theta, then the answer of theta given by that. Theta equals n pi by 3 plus pi by 12. Right. Then this equation means this, no, x is tan theta. Now I can solve this equation for x. Then since x equals tan theta, we get 3 answers for tan theta by solving this equation. Right. Then this equation when we solve, we get 3 answers for tan theta. Right. Okay. Now people, here this equation or this one also we obtained by equating tan 3 theta to 1. Here this solution also we obtain equating tan 3 theta to 1. Then the same equation tan 3 theta equals 1, we have solved first one to give theta, second one to give tan theta. Right? Then in this answers of tan theta, the angle theta should be coming by this solution. Therefore, now we can say for these 3 answers of tan theta, there are some angles for theta, no? Here, here, and here. The angles of theta are given by this solution put in different values for simple n. Okay, right. Now, we can write here this way. By this solution, putting n 0, right? I can write n 0, I can write here 0, first pi by 12 theta. Okay, theta is pi by 12. N equals 1, we can put. When you put n equals 1, right, here we get theta pi by 3 plus pi by 12. Then we get theta 4 pi plus 5, 5 pi by 12. Now put n equals 2. N equals 2. When you put n equals 2, we get for theta 3 pi by 4. Okay, right. Now, you might ask, do we need to put 0, 1, 2 only? No. Any three consecutive integral values for n we can put. Then you might say, not the same angles come in, different angles come in. No. Yes, true. But the different angles, even though you get, their tan values will again be equal to the tan values coming by this. Then why do we put this 0, 1 and 2? To get the angles just asking in the question. Okay, right. Now, what we do is, we can now write, we told the solution of this should be tan theta values, no? It's theta value only here we have, right? And then the solutions of this equation should be tan pi by 12, tan 5 pi by 12, tan 3 pi by 4. Understood? Then we can write here, put this as a star, right? That the equation we take as star, right? The equation star we can write down. Equation star has the three roots, tan pi by 12, tan 5 pi by 12, tan 3 pi by 4, right? Okay, this equation has the roots, that three tan values, tan pi by 12, tan 5 pi by 12, right? Tan 3 pi by 4, right? Okay. Now, I am going to find the solutions, the roots of this equation. That means three answers for x. But x equals tan theta, no? That three answers therefore should be what? Tan theta. Right. How to do this now? We can do it like this. Right? I can factorize this. How to factorize this? Yes, you know, when I put x equals 1, when I put x equals minus 1, what will happen? Minus 1 to the power 3, minus 1. That minus 1 and this plus 1 we can cancel down. When I put here minus 1, minus 3, minus 1, plus 3. Minus 1, when you put minus 1 squared, plus 1 into minus 3. Then here we get minus 3, here plus 3. That also will cancel. Then when you put x equals minus 1, yes, brings this left hand side 0. That means x equals minus 1 is a root. That means when you take that minus 1 to left hand side, x plus 1 is a factor. Okay, x plus 1 is a factor, right? So then you know, we learned the factor theorem, right? Thereby we can take x plus 1 is a factor. X plus 1 is a factor of this, right? X plus 1 is a factor. Then this is third degree polynomial function. One factor is degree 1. We wrote that x plus 1. People The other one should be second degree polynomial. Here like this. Ax squared plus bx plus c. All right. This way as a product, now I is supposed to write this equals 0. Now, here a we have to find. Here, when I multiply this and this, we get here 1x into ax squared. Then we get ax cubed. What is the x cubed quotient? A. But here x cubed quotient is 1. Then this a should be equal to 1. Then I can write here a equals 1. That means like this. Multiply this one. 1 and c. C. The constant in the left hand side c. But here constant is 1. Then c should be equal to 1. Right? Then I write that 1 here. Another one more thing, that is b. Right? How to find b? B can be found, people, equating x squared coefficients right here. X and bx, when you multiply, we get bx squared. 1 and x squared, when we get 1x squared. Then here, taking this x squared out, we get b plus 1 x squared. Then here, x squared coefficient is b plus 1. But here it is minus 3. Then b plus 1 should be equal to minus 3. b is equal to minus 4. Understood? b is equal to minus 4. So therefore, this is minus 4. Okay, right. Now, we factorize this. Right. Now, we can write 3 answers for x. One is coming by this. Therefore, x plus 1 is equal to 0, or x squared minus 4x plus 1 is equal to 0. Right, people? You know, here we get x equals minus 1. Right. But we told people x means tan angle, no? Tan angle equals minus 1. We told here, this equation has 3 roots, this 3. Right? Now there we found value of this 3. One value we got as minus 1. Then tan angle should be minus 1. But you know, people, tan 3 pi by 4, tan 135 is minus 1. So therefore, this minus 1 is corresponding to tan 3 pi by 4. Right. Then, this solution is coming by this. Then, this equation should give another 2 answers for tan theta. Then, the answers of 2 tan theta should be this and this. It means the roots of this equation should be tan pi by 12 and tan pi by 12. Okay? Therefore, we can write the roots of this. Roots of this should be tan pi by 12 and tan what pi by 12. Correct, no? Then what is asking? Show that the roots of this equation are tan pi by 12 and this are correct, no? That's correct. Hence, find the value of tan pi by 12. Now, people, another one asking, deduce that the product of tan pi by 12 and tan pi by 12 is 1. Right. You know, this is a quadratic equation. This is a quadratic equation. Its 2 roots are these 2. When we have a quadratic equation, the product of the roots is given by c by a, c divided by a. Then we can write by using that fact, tan pi by 12 into tan pi by 12. Product of the roots is equal to constant term divided by x squared coefficient 1. Right. Now next one asking answer of this tan pi by 12. Pi by 12 is 15 degrees. Then 5 pi by 12, 15 into 5. Correct, no? 75. Right. Now I am going to solve this quadratic equation by using the quadratic formula. by using the quadratic formula. It is x squared minus 4x plus 1 equals 0. X equals minus b minus 4 plus or minus square root of b squared minus 4 perfect square, b squared minus 4 times ac divided by 2 into 1. Right? Then here we get x equals 4. Right, there we have 16 minus 4 is 12. 4 into 3, 2 root 3, no? By 2. X dividing by 2, 2 plus or minus root 3. Okay? Then there are two answers. Right? So this x means tan theta. Right? Then the two answers, 2 plus root 3, the other is 2 minus root 3. Right? One answer of these two would be the answer of tan pi by 2, 12. The other is the answer of tan pi by 12. Now we have to separate them. Okay? The roots of this quadratic equation are these two. But we told the roots of this quadratic equation should be tan pi by 12 and tan pi by 12. That is why we say one answer of this should be tan pi by 12. Other answer is tan pi by 12. But you know, pi by 12 is 15 degrees. Tan 15, tan 45 1. When the angle is less than 45, the tan value should be less than 1. Then out of these two, 2 plus root 3 means more than 1. 2 minus root 3, 2 means 2 minus root 3. Root 3 is 1.7. No? 2 minus root 3 is the figure which gives an answer less than 1. So therefore, this should be the answer of the tan pi by 12. Therefore, tan pi by 12 should be 2 minus root 3. This is how we take that answer. Right, no? Okay, so we finish the weekly paper 3.